Our lesson on 1.5 is a really short one. It is on problem solving, and it's not short because this is not important. It's short because we've actually done a lot of problems on problem solving in the past, so we don't really need a full, huge lesson to figure this out. But what I provided for you at the top of your notes is a little model that tells you how to approach a problem solving math problem. Now, you don't have to do every single one of these steps for this class, but you'll probably informally do these. First, we're going to write a verbal model, then we're going to assign labels, and then we're going to convert that to an algebraic model. Now, once we have our algebraic model set up, we can solve it, and then we'll be prepared to answer our question. Now, I'll be the first person to admit sometimes I just kind of jump into writing the algebraic model and I skip the first two steps. It kind of depends on how much trouble I'm having with this particular problem. So you own a lawn care business and you want to know how much money you can spend on gasoline to travel to out-of-town clients. Well, a typical week, you're going to drive 600 miles. You know you use 40 gallons of gasoline, and the gas costs $1.25 per gallon. Well, this worksheet was written quite a long time ago, wasn't it? And your truck's fuel efficiency is 21 miles per gallon on the highway, but 13 in town. Now, that was a lot of information, and I'm a little skeptical that I actually need all of that information. So let's think about what happens when you figure out how much money you spend on gas. If you know how many gallons of gas you use, and you also know how much a gallon of gas costs, I think that's all you need to know to figure out your total bill for your gasoline. So basically, we have a lot of extra information. I don't need to know the 600 miles. I don't need to know the efficiency. I think all I need to know is that I use 40 gallons of gasoline and it costs $1.25 a gallon. And in order to find my total amount of money, I think I just multiply those things together. So 40 gallons times $1.25 per gallon, and I come up with $50 per week on gas. Now, I'm sure you noticed I hardly did any of those those problem-solving techniques at the top of our paper. That's okay. If you can do that without setting up all the models, I'm okay with that at this point. Okay, the next problem says the table gives the height to the tops of the first few stories of a tall building. Now, the lobby from the ground up to the top is 20 feet. Now, if you go up to the first story, which is the story after the lobby, the height of that is all the way up 32 feet. Now, that's from the ground originally. The second story goes up to 44 feet, and then 56 feet, and then 68 feet. And they want us to figure out the 15th story. Well, some people would approach this problem by just kind of continuing the pattern up to the 15th story, kind of continuing the chart. But let's think of a more algebraic approach to this, because what if I asked you something crazy like find the 181st story's height? That would be a really long problem that way. So besides the lobby, I think you might notice a little bit of a pattern here. Between every story, it looks like we're increasing the height 12 feet. So that's kind of our slope, or our rate of change for this problem. So when I'm trying to figure out the total height, what I'm going to have to think about is I got to incorporate the lobby, and then for every story after that, I'm going to increase it by 12 feet. So it's going to be 12 times the number of stories, not including the lobby, of course. So let's turn this a little more algebraic. I know that I don't have the height yet, so I'm going to call that H. And the lobby, I think, is 20 feet tall. They told us in the chart. And then 12, instead of saying times X or S stories, they told us we want to figure out the height of the 15th story. So I'm going to go ahead and just substitute in a 15 right there. Go ahead and do this on your calculator, 20 plus 12 times 15, and you end up with 200 feet. So from the ground to the top of the 15th story, it's 200 feet. And the next problem says we have to find the seating capacity of two airliners. The Boeing seats 100 more passengers than the McDonnell Douglas. And if I take one of each type of plane, the two models, I can seat a total of 696 passengers. Set up a model and solve. So, it's looking like we've got our Boeing and we've got our McDonnell Douglas. And if I were to add their capacities together, it's going to total 696. Well, I've got a bit of a problem here because they don't really tell me how much either one of the planes seats. But what they do tell me is that the Boeing seats 100 more passengers than the McDonnell. So instead of calling this B for Boeing, how about I call it McDonnell plus 100? And then if I still add that to another McDonnell, it's got to be 696. So using our algebraic techniques of combining like terms, I get 2m plus 100 equals 696. Let's divide or subtract 100. So 2 McDonald's is 596. And then divide by 2 on both sides, and we get a McDonnell seats 298. Well, I can't stop there because I think they also want to know how much a Boeing sits. And remember, they said the McDonnell plus 100 would be the same amount as filling up a Boeing. So if I take 298 and add 100, I've got my Boeing. Now this means nothing if you were going to run up to some CEO of a company and show him this. So you're going to have to tell him in simple form, what does this mean? So we're going to tell him that a McDonnell seats 298 people and the Boeing seats 398 people. Okay, moving along. A rental car company charges an initial fee of $4 per ride, and then it also charges 23 cents for each mile. And they just want you to write an equation that describes the relationship between m miles and c cost. So we're not actually going to find an answer, we're just going to write an expression. And the reason this is important is because if you were going to program a computer or a cash register, no one wants to calculate every single one of these answers every time they have a customer. So that's why we have to program the machine, and the machine understands simple algebraic logic. So let's think about our total cost. Our total cost for our rental is going to be the initial fee, which they have to charge everybody. And then let's say our 23 cents times the number of miles. Well, let's fill in what we know. Cost is C, I don't know that. Our initial fee is $4. And then 23 cents, they don't tell me the number of miles, but they want me to use the variable m. And I think we're done. They just wanted the equation that we would use for our computer or for our cash register, and we have it all set up, and now it can calculate anything that comes through our door. That concludes our lesson on 1.5.